Hello guys, so in this video we are going to discuss a special type of question that is usually asked in your SAT exam. You might as well watch the video if you are preparing for any mathematics exam at all, because you can be asked questions that will test your knowledge on these. Now this is our last but one video or lesson on percentages. Our last lesson on percentages, we are going to solve questions relating to these two cases. We are going to solve questions by applying the knowledge that we are going to gain in this video. Now you have two main cases of questions involving mixture concentrations in mathematics. The first case is that you are given two samples or two solutions, and these two solutions are mixed. Okay, now when they are mixed, you have a resultant solution. Now you are given the percent composition of your first solution, the percent composition of the second solution, and then you have the masses of both. Okay, and then also the mass of the final solution. So these 5 variables are what you need to set up an equation for this situation. So usually in a question, you will be given 4 of these variables, and you'll be asked to find the fifth one. Now, how are all these variables related? So you have the percent composition of the first one, that's X%. So you have X% glucose by mass of solution. Solution A has X% of glucose by mass. So you have X% here. Okay, X%. You multiply that by the mass. That's A. Okay, so you multiply that by the mass. That's A. And then plus the percent composition of the next solution, that's B here. So you have Y% multiplying what? B. That's the mass. And then this will be equal to the mass of the resultant solution, that's in this case C. So this is the equation you need. So in any situation or any question where you are given a problem where 4 of these variables are given but one of them isn't there, you use this equation and then you can find your answer. So let's take an example. So you have two solutions that are mixed. Solution A has let's say 20% of glucose by mass. Okay, so 20% of glucose, so you have 20%, 0.2 by mass, and then the mass of solution A being, let's say, 1 kilogram. Okay, 1 kilogram, and it is added to another solution which has 30% of glucose by mass. So you have 0.3 here, multiplying by mass. Okay, but then we are not giving the mass of solution B, so we don't know. So solution B, so you put B there for it. And then we are giving the mass of the resultant solution to be, let's say, 3 kilograms. Okay, now you're asked to find the mass of the second solution, that's solution B. Now we have an equation set up from our equation here. Okay, so you have 0.2 by 1, 0.3 by B equals 3. So you simplify it, you have 0.3B here, 0.3B. You move 0.2 to the other side. So you have 3 minus 0.2 giving us 2.8. 2.8. Now B will be what? 2.8 over 0.3. 2.8 over 0.3 is the same as 28 over 3. 28 over 3. And then you know 3 going to 28 9 times. Okay. They have 9. That's 27. 1 over 3 be 9.3. So you have 9.3 kilograms for solution. So this is how you go about it. Whenever you're given a problem where I've been any of these 4 variables and you have to find the last one, use this equation and you are fine. Now let's go to the second case. The second case, you are given the percent composition of the 2 solutions you are adding plus the percent composition of the resultant mixture. Okay, then they are given the masses of each of the solutions, that's the 2 solutions you are mixing plus the final solution. In this case, you have about 5 variables being given as well. Okay, 5 or 6 of them. So let's see. You have your percent composition being, you have your percent composition of the first one, percent composition of the second one, percent composition of the third one. Then you also have the masses of the 3 of them. So if you have a case like this, I think there are 6 variables here. You are given 5 of them. And you're asked to find the last one. Then that's what you're going to use. So in this case, you have X%, okay, times your A plus your Y%, okay, times your B Okay, returning to your B, and this will be what? Your Z percent, that's the last one, your Z percent times your C. Now you're not done. Remember, in this case, you be given the masses of each of the solutions. So let's say this is 8 kilograms. Okay, this is 8 kilogram. This is 8 kilogram. This is B kilograms. Okay, and this is C kilograms. So in this case, C kilograms. So in this case, your next equation is going to be A plus B. Okay, A plus B equals C. Okay, so now you have system of equations, 2 of them. So depending on which variables you are given, you just do your normal substitutions and the rest is algebra. You just do your normal change of subject substitution and then you have your answer. Very simple. So these are the 2 cases that we are going to encounter in our SAT exam or any other mathematics exam that you're going to face. So make sure you study both cases well, know what variables are given in each case, you know how to do your substitutions and then change your subjects and then find your final answer. Now in our next video, we are going to solve some examples in which you will have to apply the knowledge from these cases. See you in my next video. Bye.